Now let's move to the question number 9. The curve is such that second derivative is equal to 6 over x to the power of 4 minus 5 over x to the power of 3. It is given that curve has the stationary point at half comma 9. Stationary point SP is equals to half and 9. So it's mean first derivative of the curve at this stationary point is equal to 0. From this statement you can see that first derivative of the curve at the stationary point is 0. Secondly, you should also know that this stationary point lie on the curve. Use this expression for second derivative to determine whether the stationary point is maximum or a minimum point. To find the nature of the stationary point, we always use the second derivative and plug the stationary point in the second derivative equation. To find whether the second derivative at stationary point is positive or negative. So we have the second derivative, which is 6 over x to the power of 4 minus 5 over x cube, plugging the stationary point. So we just need to plug the x coordinate of the stationary point, which is x is equal to half. So 6 over x to the power of 4, so means half to the power of 4 minus 5 over half cube. So this one is equals to the 6 times 2 to the power of 4 minus 5 times 2 to the power of cube. And this one is equals to 6 times 16 minus 5 times 8. And this one is equals to 96 minus 40, which is equals to the 56. So we have find out that the second derivative at the stationary point is 56, which is positive. So we can say that this one is greater than 0. By plugging the stationary point in second derivative, the value is positive, means the stationary point is minimum. So we can say that stationary point is minimum point or minima. Part B, find the equation of the curve. To find the equation of the curve from the second derivative of the curve, we use the integration. So d second derivative with respect to dx square is equal to 6 over x to the power of 4 minus 5 over x cube. By cross multiplying, we will have dy square is equals to the 6x to the power of negative 4 minus 5x to the power of negative 3 multiplied by dx square. Integrate both sides. So we will have integration of dy square is equals to dy, which is equals to integration of 6x to the power of negative 4 minus 5x to the power of negative 3 with respect to dx square. So we will have integration of 6x to the power of negative 4 is x to the power of negative 4 plus 1 over power, which is negative 4 plus 1, which is negative 3 minus 5. Integration of x to the power of negative 3 is equals to x to the power of negative 3 plus 1 over power, which is negative 2 plus constant, and this one is multiplied by dx. So we will have dy is equals to, this one will be 2. So we will have negative 2x to the power of negative 3, and this one is equal to plus 5 over 2x to the power of negative 2 plus c, and when we switch dx on the left side, it will be over dx. Okay, this is a derivative equation, but there is an unknown c, so we need to find this constant. How we can find it? We can find it by using this information. We know that derivative at stationary point is 0 and stationary point is given. So when we plug stationary point in the derivative equation, we get the value of 0. So derivative at stationary point is equal to 0. So we can plug dy over dx at x is equals to, x coordinate of the stationary point is half. and this one is equal to negative 2 x to the power of negative 3 plus 5 over 2 x to the power of negative 2 plus c when x is equal to half, and this one is equal to 0. So we can write it negative 2 over x cube plus 5 over 2x square plus c when x is equal to half, and this one is equal to 0. So negative 2 over half cube plus 5 over 2 times half square plus c is equal to 0. So this one will be cancelled out, and this one is equal to the negative 2 times 2 cube plus 5 times 2 plus c is equal to 0, and this one is equal to negative 16 plus 10 plus c equal to 0. So we can say that c is equal to 6. Plugging this value of c in this equation, we get the derivative equation. So dy over dx is equals to the negative 2x cube plus 5 over 2x to the power of negative 2. This one is negative 3. Plus c means 6. So this is the derivative equation of the curve. We need to find the equation of the curve. So we need to integrate this equation again to find the equation of the curve. So this equation can be written as dy is equals to negative 2x to the power of negative 3 plus 5 over 2x to the power of negative 2 plus 6 and multiply by dx, and then integration. So we will have y is equals to negative 2 integration of x to the power of negative 3 is negative 3 plus 1 over power which is negative 2 plus 5 over 2 x to the power of negative 2 plus 1 over negative 2 plus 1 is negative 1 plus 6x, and in this case constant will be k. So further solving, we will have this one will be cancelled out, and we will have x to the power of negative 2, and then this case we will have negative 5 over 2, and this one is x to the power of negative 1 plus 6x plus k, and this one is equals to y. Again we have another unknown k, so we need to find the value of k, and how we can find it? By using the information that stationary point lie on the curve. It's mean stationary point which is 1 over 2 9 lie on curve. So it's mean this point satisfy the curve. So plugging this stationary point in this equation, because this point satisfy the curve equation, so we can find the value of k. So this one is x and this one is y. So plugging, we will have x to the power of negative 2 means 1 over 2 whole power negative 2 minus 5 over 2 x inverse means 1 over 2 whole power negative 1 plus 6 times half plus k is equals to y is equals to 9. So we can write it 1 over 2 to the power of negative 2 minus 5 over 2, and this one is equals to time 2 to the power of negative 1 plus this one is equals to 3 plus k equals to 9. So this equation can be written as 4, and this one is cancel out, and we will have negative 5 plus 3 plus k equals to 9. So this one is equals to negative k plus 2 is equals to 9, and k is equals to 7. So we have calculated the value of k. So plugging k in this equation, we get the equation of curve. So equation of curve is equals to x in to the power of negative rho is equals to x is 1 over x2 x square minus 5 over 2x plus 6x plus k, and we just calculated the k which is 7 equals to y and this is the required equation of the curve.